This conference will now be recorded.
Oh, welcome everybody. I trust you can hear me. My name's Rosie Sheldon and I work for TSG Training. I'll be presenting the webinar today. Just a bit of housekeeping first. During the presentation, you'll all be on mute. But if you have any questions, please put them in the chat box and we'll have a Q&A session at the end. I'll be talking about the BCS Artificial Intelligence courses today. And if you want to know more, please do contact us. It's tsgtraining.co.uk. Both the AI Essentials and the AI Foundation course are in August and in September. This webinar is being recorded and will go onto our website within the week, tsgtraining.co.uk. Today I'll be talking about why AI is such an exciting and relevant field, what it is, what its roots are, and where we are now, and indeed what the future might hold. And these topics are both in the Essentials and in the Foundations course. I'm not going to go through what the courses cover today, but rather give you some taster of the contents. So these are the two AI courses that BCS offers. Both have exams leading to certification. The Essentials course isn't a prerequisite for the Foundation, but rather they're designed for different groups of people. And the syllabi are on the TSG Training website. Seems sensible to check we have a shared understanding of what artificial intelligence is first, and the start of that is to understand what human intelligence is. I'm assuming you're human, so I won't ask how human are you feeling today, although it's always an interesting question. But part of being human is having different senses. You can see the screen, I hope. You can hear me, I trust. I hope you're in a comfortable environment, not too hot, not too cold. Have you got a tasty drink on the go? But being human is more than having senses and receiving data. At its essence, it's being able to learn from experience, adapt, understand, handle abstract concepts, manipulate the environment. Put slightly differently, quickness of understanding, wisdom, the collection of information. Or differently, the ability to to understand and learn, make judgments, or have opinions that are based on reason. Good old Wikipedia. What about problem solving, reasoning, self-awareness, creativity, emotional knowledge? So the different definitions about what human intelligence is, but where have these come from? What's the history behind our understanding of intelligence? And typically people go right back to the 4th century BC, to Aristotle as the father of Western philosophy. There's quite a bit of philosophy and ethics in AI. He lived from 364 BC to 322 BC. I had to look that up. And he was the first to write about objects and the natural sciences. And he laid the foundations of ontology. That's the nature of being, knowledge, engineering, and the scientific method. That's the empirical way we acquire knowledge through careful observation. That's taking in data. Rigorous skepticism. We formulate a hypothesis. We test with experiments. We redefine that hypothesis. So as you can hear, we're working iteratively, cyclically. We build on our results. And what we're doing, of course, is learning from experience. And we publish our results, which means others can review our work. We're being transparent. Now, the scientific method and learning from experience led to machine learning, and that's part of AI. It helps us today, and I'll talk a bit more about it later. It's a very large part of the foundation course in particular. And human intelligence led us to the industrial revolutions. The first spanned from the mid-18th to the mid-19th centuries in Europe and the US, and the steam engine was developed. Rural societies became urban, industrial. It started with the mechanization of the textile industry, and tasks previously done laboriously by hand in hundreds of weavers' cottages were brought together in a single cotton mill, and the factory was born. The second industrial revolution was shorter, about 1870 to the First World War, and here electricity allowed for mass production, and the commonly quoted example being when Henry Ford mastered the moving assembly line, and there was technological advances like the internal combustion engine, telephone, light bulb. And then the third revolution started in the 80s. I remember this one. Manufacturing going digital with personal computers becoming common. Digital and information and communications technology began to be embedded into society, including, of course, the internet and automation. And the fourth revolution is now. And it's exploiting the third revolution, the digital revolution, and it's driven by a wide variety of technologies, and AI is one of them. So there's AI, robotics, Internet of Things, plastic printing, nanotechnology, bioengineering, and some of you might use Siri. I'm sure you've heard of autonomous cars, maybe closer to home. Your car has automatic parking. So AI is out there and we're using it. Machines are great at doing some things, like dealing with data, making fast calculations, predictions based on algorithms, working in extreme environments like space, deep water, and humans are good at doing different things. But more than that, all humans are not the same, and different people are able to do different things. So we must design for all, so that all can benefit. And this is universal design. Can I just interrupt you at this point and ask you all to put yourselves on mute? I thought I had, but if you could just check, please, I'd be very grateful. I will just try again my end too. So back to universal design, design for all. The idea being, as a consequence of universal design, we should all become more human, more true to our own DNA. Then we can do more of the things machines can't do, but that we're good at. And Doherty and Wilson describe these as the human-only tasks in their book Human and Machine. They describe them as leadership, ethics, judgment, creativity, and you can see these included from the definitions earlier. And other examples are tasks that involve ambiguity, awkward tasks, higher value tasks. These are things we're good at. But how can AI help us? Well, artificial intelligence can be seen as a universal subject. It pulls from so many different areas and expertise rooted in Aristotle, and areas like computer science, data science, natural sciences, social sciences. And so far, though, I've talked about intelligence, human intelligence, but this in itself can be subdivided and possibly into as many as 8 different components. And one part is IQ, the intelligence quotient. And that's the total score from a set of standardized tests, and it comes out of the scientific method. But human intelligence is much, much more than IQ. Human intelligence also includes emotional intelligence. So what's emotional intelligence? Well, it's understanding ourselves and others, and then using this understanding to adapt to and change the environment. It's about being able to empathize. It's about being able to make a judgment. So then, how could an autonomous, that is an intelligent robot, have empathy without emotional intelligence? And what do you think about having an autonomous robot without empathy? So this makes the question of autonomy more critical. And the hardest problem in AI is consciousness. We are conscious, but we don't yet understand it or have a clear theory of it. And in fact, we don't know why we have consciousness. In contrast to human intelligence, so what's artificial intelligence? What do you think it is? It's intelligence demonstrated by machines. There's the computer science view that intelligent agents perceive their environment, take actions to achieve a goal. But firstly, what's an agent? Russell and Norvig define an agent as anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Perceiving its environment through sensors and acting upon that environment through actuators. So according to this definition, humans, robots, and programs are agents. Do you remember at the beginning I asked you if you could hear me, if you could see the slides? So a human is an agent. We have sensors, the eyes, actuators like the hands, which are in this case also sensors, and we interact with an environment, our world. There are different sorts of agents, and these are covered in the foundation course. Model-based, where the agent has an internal model of its environment. There's also goal-based agents, which need a goal in order to implement the agent's functionality, and utility-based reflex agent, where there's a measure of how useful the action is. But all of these definitions miss the point of emotions, what emotions are. So to wind back, intelligent agents are autonomous, and they're known for their ability to sense a situation and react. And Russell and Norvig considered goal-directed behaviour as the essence of intelligence, and they preferred a term borrowed from economics of rational agent over intelligent agent. So focusing on the goals, some traditional goals are sometimes called narrow or weak AI, like reasoning, planning, learning, natural language processing, image recognition. We're already really good at narrow AI. Engineers and scientists use this every day. It gives us superhuman capability. Searching the internet in seconds, surgical robots, identifying patterns in vast quantities of unstructured data. It can give older people or disabled people more independence, voice control. I really fancy an autonomous vacuum cleaner or an autonomous lawnmower. What about drone delivery? Narrow AI. But there's also artificial general AI, sometimes called strong AI. And this performs a full range of tasks, and some predict it will be 2050 before we can actually achieve it. We're not sure, actually, if we'll ever understand consciousness. This strong AI will be able to perform a full range of tasks, but it's a long way off. So we've got weak AI and we've got strong AI. But before I leave this definition section, I want to stress that automation is not the same as AI. There's no learning by experience. It's only automatically controlled operation of an apparatus, process, or system by mechanical or electrical devices that takes the place of human labour. That's not AI. There's no learning from experience and no human involvement. The history of AI starts with Ada Lovelace writing the first computer program. And then there was another critical step when the famous British mathematician Alan Turing created the Turing machine, and that helped win World War II. And then these methods were developed through the 1950s, when Turing wrote an article that defined what is now known as the Turing test. I'm sure you've heard of it. And this is a test where the human converses with two entities, one human and one computer program, over a text-only channel, like a computer keyboard screen, and then attempts to determine which is the human and which is the computer. To pass, the computer has to be able to carry on a conversation so convincingly that it's as if two people are talking. It needs to be able to generate its own thoughts, responding to questions and statements. And this method to determine whether a machine showing behavior can truly be called intelligent has significantly influenced research on AI. But there's also been AI winters, where promises made weren't met and funding dried up. So the challenge was how to make machines as intelligent as humans. And to do this, we had to work out why and how humans were clever, which is why, of course, I started with human intelligence. How do we learn? We learn from experience. A machine learns from experience by analysing data. And machine learning is a scientific way of analysing data. So the scientific method plus learning from experience gives us machine learning. But there's a problem with machine learning. There's just not enough computational, not enough computer power for the combinatorial explosion. So we need heuristics. A heuristics is a strategy derived from previous experiences with similar problems. So in machine learning, heuristics means a technique for solving a problem more quickly where classical techniques are too slow, a bit like a shortcut. In the course, we talk about trade-offs, developed using trial and error, discovery, experimentation. So the experts teach the machine learning algorithm how they do it, and that transforms the problem into a simpler form that's easier to work with. And both the Essentials and the Foundations course cover machine learning, more so in the Foundation, which has also got a very large section on robotics. Now, I started this section by saying that the AI challenge was to consider how to make machines as intelligent as humans. I've talked about machine learning, learning from experience by analysing data. But what can we learn from the brain? How can we model the brain itself? And artificial neural networks do this. And at their most basic, with three layers, we've got the input layer, where data enters the system, the hidden layer, where information is processed, and the output layer, where the system decides what to do based on the data. And the artificial neural network can get much more complex and include multiple hidden layers. But whether it's three layers or more, information flows from one layer to another, just like in the human brain. So an artificial neural network made up of more than three layers, so you've got an input layer, an output layer, and multiple hidden layers, is called a deep neural network. And this is what underpins deep learning. And a deep learning system is self-teaching, learning as it goes by filtering the information through the multiple hidden layers in a similar way to humans. And deep learning represents the very cutting edge of AI, of artificial intelligence. So instead of teaching computers to process and learn from data, which is how machine learning works, with deep learning, the computer trains itself to process and learn from data. And that's all possible due to the layers. So deep neural networks are important as they very closely match to AI, robots being able to learn by themselves. So this closely matches the AI intelligent agent concept, because agency is key, free will. AI gives robots agency, the ability to make their own decisions. Do you remember the fourth industrial revolution that's exploited the third, the digital, driven by AI? Well, driven by cheaper supercomputing, there's been a huge increase in the speed of change. And these are some of the technologies that have become commonplace. So we've got AI and machine learning have given us significant opportunities. And the fourth industrial revolution has the potential to change every aspect of our lives. Let us be more human, with the machines doing the grunt work. We can reimagine the future. We can work together. Do you remember Design for All? Well, demographics show that we're living longer, need more help. Intelligent products can improve our standard and the quality of our lives. Smart cities are more sustainable, more sociable, safer. Smart homes can provide home care, well-being, security. What about smart wearables? Clothes, watches, phones that look after us. So AI is an opportunity to leave a better future. And it even gives us the chance to consider intergenerational equity and leaving a better future for others. The EU's ethical guidelines want AI systems to have an ethical purpose, to be human-centric, trustworthy, as well as technically robust, which leads us on to ethics. I mentioned earlier when describing the scientific method the ethos of publishing results so that others can peer review our work. Our work's transparent, it's reproducible. And this idea of openness and transparency is a common theme in AI. There's lots of open source code available, and there's a culture of developing AI for good. So ethics is key for AI to develop for all. And there's guidelines and standards available. But, and this is a big but, we don't know what will happen if super AI develops consciousness. But we need to stay engaged with AI, not to step back, afraid of the future. Humans are fundamental, an integral part of reimagining our lives with AI. We've got to engage, got to set the goals, consider the ethics. And deep neural networks give us a way of allowing machines to learn. Robotics in particular is one area that will benefit. But there's unknowns. Artificial intelligence is a diverse, fascinating, complex, rich subject that's growing and learning. And through it, we can hope to even leave a better future. The AI course provides a fascinating overview and a foundation to AI, and I hope to see you maybe at one of them. But thank you for listening, and I'll take any questions in the last few moments. Here on the slide, you can see how to contact us. And as I said, this has been recording. Thank you. Thank you for your question. No code is taught in the course. No, we talk generally about Python being a very common language used, and about what is open source and available, but nothing is explicitly, no code is explicitly taught in the course. No. I'm going to stop the recording now, but if anyone's got any other questions, please do pop them into chat. I'll be happy to talk.